Greatest results always comes with collaborative
MG, I need... Oh, sorry. I didn't know you're recording a video. See you later.
Wait, what are you up to now?
MG, I need your mobile password. I have it actually here.
My mobile phone password?
Yeah, listen, I'm training MG personalized virtual assistants over mobile phones, and for training that machine learning model, I'll need my mobile phone data sets and your mobile phone data sets.
Of course, I'm not going to share my mobile phone data set because these are private.
Okay, that's your phone. This is the laptop. And that's my phone. I'll keep it. You just train the machine learning model by yourself. And by the way, don't ask me to train any machine learning model anymore. See you later.
Wait, there's a solution. We can use federated learning. Let's give it a try.
I don't care anymore.
Anyways, with federated learning, you can still have your dataset decentralized, and there's no need for sharing your dataset and keep them centralized for training machine learning models. Well, let's try to figure out how we can train our models with decentralized dataset without the need of sharing them. Let's go! Hello everyone, this is MG and welcome to this video. Well, in some of your machine learning projects, you might have been probably faced up with the challenge of accessing to the data or sharing data sets. For example, due to some specific privacy or regulation frameworks in place, you're not allowed to share data or get access to the data. And now the main question would be, how can I train my machine learning model without sharing data and even have the data in a centralized place? Well, the answer is federated learning. With federated learning, instead of sharing the data to a centralized place, we can keep the data decentralized and without even asking the other stakeholder to share the data with us. But instead, we will ship our machine learning model parameters to those places and let the parameters get updated, and then we will aggregate the parameters updates from my machine learning model to a centralized orchestrator and have the machine learning model finalized there. So with this technique, we don't really care about the dealing with the challenges of accessing to the data or sharing data. We do not even need to share data, but still we can have our machine learning model get trained. Now, federated learning has a ton of applications. As of now, we can talk about healthcare since it's dealing with sensitive patient data and they cannot get necessarily shared. Or in your mobile phones, right now we have so many machine learning models running in our mobile phones, and they have been trained with so many individual mobile phone data sets. For example, the machine learning model that can complete what you're writing down when you're texting someone or chatting with someone. There's a machine learning model to sort of predict what you're writing or complete the current word that you're typing, right? These models has been trained with the pattern of people texting their mobile phones, but the people data sets and patterns, which can be personal data sets, are not getting shared to a centralized place. So the data is still here, and the machine learning model parameters will get updated with the data have been sitting in a mobile phone without getting necessarily shared to a centralized server. So enough talking, and let's check it out how we can enable that on Azure. Then let's check it out.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. All right, now let's get into what is federated learning. Well, before we get hands-on and see how we can implement federated learning on Azure, and I'm going to show you actually an accelerator that how you can quickly implement federated learning examples as a great start and also learning platform for you to get hands-on, understand what is federated learning. Let's, before we jump in, talk about what is federated learning in general and what are the benefits. So let's say, as we talk at the intro of the video, you might have some specific scenarios that you cannot share the data because of any different reasons, and one of the most important one is having private data in place. For example, here, and in this whiteboard, I did my best to draw a beautiful one. Sorry if it's not that good. But here we can see I have multiple devices. Number one here, number two, number three. These are, for example, mobile devices that they have sensitive or private data. And we're gonna train machine learning models using the data set under each of these devices, but we cannot share the data, right? So what is the solution? If I don't have all data in a centralized place, how can I train machine learning model? Mobile phone or mobile data is an example here. That can be different organization, different institute. Let's say for healthcare, these number one, two, three can be different hospitals that they have their own data, but they cannot share. So how we can have model get trained with distinct data set in a decentralized manner. So instead of calling them mobile phone instance, whatever, let's call it silo. So we have silo number one, silo number two, silo number three, right? This is what we're going to call actually when we implement it on Azure. And now as you can see, within each silo, we have certainly data. And what we're going to do with federated learning, instead of having all this data set coming into a centralized place, as you can see, I'm not moving this data. We keep the data wherever they are, but instead we bring the model training and model parameter update to that device or to that silo. So you can see that a portion of my parameters stuff or training gonna happen here at silo number one, and these model gonna get updated with some parameters. The same thing in silo number two. With the portion of the data set that I have here, I can update the parameters of this machine learning model. Let's say here's neural network and I have weights as one of the parameters that I need to update them with the portion of the data that I have in silo number two. And the same thing here, I have the data here, and using the portion of the data as at silo number three, I can train this model with the parameters. Now I have multiple parameters in different places get updated with different portion of the data. Portion number one, portion number two, and portion number three, right? So now what I'm gonna do, I will bring them all to a centralized place. You can call it, let's say, orchestrator, blah, blah, blah. And then I can then aggregate the parameter updates that I got from each silo. I bring them all to a centralized place and average them. Now I have the average or aggregated results of all those parameters I updated with different portions of the mobile devices, silos, or whatever. And there you go. I got these sort of finalized aggregated parameters. Now I can do this iteratively. I can push this average one back again to this device or to this silo, and then to that silo again. Let it get updated with the portion of the data I have here, with the portion of the data I have here, here, and again bring the results back and get them average. So you can see iteratively, instead of me shipping the data set to a centralized place, I keep the data wherever they are. Instead I sort of decentralize the model training process and ship them to different silos and let the parameters get updated locally in the place that I have the data, and have the average result centralized, which is here. This is exactly what we're going to do, and you will see in Azure ML we will have an Azure ML as an orchestrator here, and then for each silo we will have different compute clusters in different regions. One of them is in US, one of them, let's say, in Europe, whatever. And we can see how with this Azure ML orchestrator I can call these different computes that they have access to different portion of the data to update the parameters of the model and have them aggregated in multiple, I think 3 or 4 iterations we're gonna do it actually. And this is extremely useful. And the accelerator that is actually I'm leveraging, I'm gonna show you, they have already benchmarked that how gonna be the result or the performance of my model when it is trained through federated learning or this approach, rather than having all data in one place and training data model in one place, which is a typical machine learning project, right? Okay, now let me dig into that accelerator and GitHub repository that I'm gonna share that in the video description. Alright, here you are. I am under Azure ML samples, Azure samples, and there is a public GitHub repository called Azure ML Federated Learning, and kudos to contributors here. We have federated learning in Azure ML. So what this repository gonna provide, it's sort of an accelerator. It will give you the initial understanding and hands-on codes that you can leverage to start building your own scenario, because your own scenario might have specific security questions and assessment in place. So definitely it needs some further customization beyond this repository, but this is actually a great start, and I will show you a demo that I actually implemented, which is pretty close, I would say, to a real scenario that you want to implement. But again, you might have a specific requirements in place. So coming in, this repository will actually give you a quick start. I think within a couple of minutes, as it says here, with several minutes, you can have that quick start federated learning implemented on your Azure subscription. Plus, it will give us some real world examples that how through federated learning, the approach that I just mentioned, you can train a model for medical imaging, I think for detecting pneumonia from face versus a normal chest X-ray image. Some name entity recognition, that's an NLP use case. And the one that I actually tried and I'm going to show you and provide you walkthrough how I implemented that is fraud detection. So we will come to that, and okay, let me open up that fraud detection and see what this is about. So in this scenario, this use case is actually using Kaggle dataset called credit card transaction fraud detection dataset. So actually open that up. Let me show you quickly. So that's a simulated credit card transactions that contain some information. Let's say, let me show you actually the data here. There you go. The transaction date and time, the credit card number, the merchant location, category, the amount of transactions, so on and so forth. So that's sort of a simulated data set, but regardless, that can be any other tabular data set. Now coming back to the repository, what we're going to do first, we are going to actually clone this GitHub repository to our Azure ML to get access to these examples and samples and see, okay, how we can implement that demo or use case, which is very close to the way that you implement this is exactly or very similar to other use cases that comes with this repository. All right, so let's start. First, as it says, before you start implementing this example, you need to have the infrastructure created on Azure for deploying this use case. Then the question is, how can I implement that infrastructure or services needed? Well, this repository did a great job on providing those infrastructure for you. With just a click on deploy, you can do that. So it says for running this example or any other example in this repository, you need to provision one of our sandboxes. Okay, let's do that. So we go to sandbox. It is nicely providing us almost 1, 2, 3, 4, 5 different type of sandbox we can implement. And I would say from sequence that has been added here, the first one is the less constrained or restrict environment, and when we go further, it's going to be more constrained environment. What does that mean? For example, the first one going to be the very minimal sandbox that you can have the demo environment there, but if you want to be a little bit more constrained or more picky, I would say the second one will implement that infrastructure with virtual network stuff, so more access control, but still the data will be accessible by users. But you might say that no, I actually want to have my infrastructure deployed with virtual network stuff in place, private endpoint in place, make sure I have access control, and also nobody or no user can see the data, but the computes that are gonna train the model can see the data, right? So this is actually the sandbox, and I actually implemented this one for that use case to implement that credit card fraud detection. And the other one is confidential VM. So in case, oh sorry, I clicked on that. In case you want to do the same sandbox, but you want to have confidential virtual machines, that's the other type of sandbox you can go with. And if you might question what is confidential compute, that's sort of type of a confidential implementation that will happen into the compute level. So that means the compute will encrypt the data in memory based on a hardware based system, and then the decryption gonna happen after validating the environment and cloud environment that getting access to the data is safe. So that's a more sort of consideration about security and access controls over the data. And the last one gonna give you a customizable sort of environment that you can implement in case you want to have that infrastructure as a code modified by yourself. So I go with this one, and let's see what is the Deployment process. Well, I have 3 deploy options. The first one will give me 1 compute per silo. Again, if you ask what is silo, I'm gonna refer it back to this very professional whiteboard session. So silo gonna be, let's say, the environment that has a portion of the data, and we're gonna portionally train some parameters of the model. Silo 1, silo 2, sample 3, right? So I want to have just 1 CPU compute per silo, which is more than enough for me because that credit card fraud detection is not crazy heavy, or I don't need GPU stuff for that. So the first one would be enough for me. But before I implement, I'm going to show you how does the architecture of that solution going to look like. Well, as you can see, these silos are the ones that I again showed you. For example, this is the orchestrator, which is here. And then these silos that I talked about are going to be silo B, C, D, so on and so forth. Then how that whiteboard that I just showcased you here going to get translated on Azure? This is the answer. Well, we have Azure ML Workspace. It will implement an Azure ML Workspace in a region, let's say region East US as an example. And then within this Azure ML Workspace, I will have a compute cluster that act like an orchestrator, which I explain what is orchestrator. And that orchestrator will handle different silos or different computes that are in different regions, let's say region B, C, D, and each region or each silo has access to a portion of the data in a separate storage. So region B has access to the storage account in region B, region C, storage C, region D, storage D, so on and so forth. And you can see these compute and these environments are secured behind a virtual network, and this compute can access to that storage just through private endpoint. That means me as a user, I cannot even open this storage account and see the data, but that compute through manage ID can access to this storage account, and also private endpoint is enabled for them. The same thing for the orchestrator, and the same thing for rest of the regions. And optionally, you can also do VNet peering if possible through the different regions that you have for facilitate the communication between these computes. All right, so let's click on deploy, and as soon as you click on deploy, it will navigate you through your Azure portal, and it will ask you to fill out some specific information about your subscription, the resource group you're gonna implement, the region. I'll keep it as East US, the demo base name. The default name is FL demo, but I change it to FL demo MG. Orchestrator region, keep it as is. The silo regions, it will give you 3 silos, and each silo going to be different region. One of them is in East US. Let's say a data set that we have is in East US, and the other portion of the data set that we have in West Europe. Again, we don't want to share the data, let them be there. We're going to do the model update, parameter updates there. And that's it. So you can decide on if you want to do VNet peering. And lastly, which is very important, it needs your Kaggle username and Kaggle key. Why? Because the dataset will be downloaded from Kaggle as an example to train the model. So how you can grab Kaggle username and pass? Well, log into your Kaggle, as I did, and if you all the way click on right, go to cons, you can see my username here, MG. And what is Kaggle key? Key here is not your Kaggle password, it's your Kaggle token, API token. So click on create new API token. It will give you one which is confidential. Copy that, and when you come here, paste it here. So on backend, this deployment gonna create key vault, and it will store them in that key vault. And when you deploy the example pipeline, it will know where should it grab those credentials and download the data needed for training. That's, you click on review and create. It will launch all those resources you need that we talked about that in the repository, the Azure ML orchestrator, all those computes, private endpoints, virtual network stuff, and ready to go. So I'm not going to deploy it again because I already did. And to save the time, I'm going to show you what you will see after deploying that in your subscription. So now moving back to my resource group, I'm gonna type FL demo MG because that's sort of a base name I use for all the resources that they're gonna get created by this repo. And there you go. You will see that there's an Azure ML workspace created, which is sort of my orchestrator. And you know that with Azure ML, application insights come with it, container registry comes with it, and key vault comes with it. And log analytics workspace stuff can also come with it to store the logs and get the logs fetched for a specific monitoring purposes. Now you can see that it also created 4 different private endpoints. Let me 1, 2, 3, 4, actually more than 4, because it's not just for the computes. It created, silo 0, silo 1, and silo 2. So 3 silos. These are different portion of my data set that there are in different regions. These are those mobile devices, or these are those hospitals that they have their own data set. For example, one of them is in Australia East, one of them is in East US, and one of them is in West Europe. And you can see if I click on any of them, they have their own virtual network. There you go. These are the virtual network. My orchestrator has a separate virtual network compared to the rest. So if I click on, let's say, silo 0, if I go to containers, if I click on private, I don't see the data. I don't have access to that, right? Because it's secured behind virtual network, but the computes can access to that. And if I click on networking, you'll see that it says that accessing to this is disabled, but there's a private endpoint already enabled for this, which is great. So coming back to the resources created by this accelerator, I have managed IDs created for the computes, the virtual networks we talked about, and a key vault that this one is actually also storing all those sort of Kaggle username and key stuff that we talked about. And network security groups and interfaces are created for those virtual networks as well. All right, so let me open up my Azure ML workspace, which is an orchestrator. And you can see here, I actually have it open. Let me switch my screen. There you go. And when I clicked on compute, I realized that, well, I have those compute clusters created, which are the silos, and each of them, as you can see, they are in different locations. And if I click on any of them, they are secured in a virtual network. Compute silo 0 is secured behind virtual network silo 0. If I go to another compute, let's say go to silo 2, you can see the virtual network for that compute is in silo 2, and it has also assigned and managed identity for, let's say, access into the data. So now I already created a compute instance as well to clone the GitHub repository that I showed you, and I can show you quickly how I did. So you just go, let me see if I have it already open. There you go. So if you click on notebooks, you can click on open a terminal. It will give you an Ubuntu terminal. You can just simply say git clone, and Git is already installed in Azure ML computes. And paste the URL that I'm gonna add in the video description, which is the URL of the repository that I showed you, and hit enter, which I'm not going to do it again, but after you do so, Azure ML Federated Learning folder will be created with the all examples underneath. Now, what I did, I created a sandbox, an infrastructure that I can implement my federated learning with all computes, with orchestrators, silos, private endpoints, virtual network, everything is in place. I have my Kaggle username and password to download the credit card fraud detection. And now I want to see how can I start implementing that demo using the examples provided here. So you can see the examples are actually, let me actually close the extra folders to make it less messy. All right, you can see that I have CC fraud, credit card fraud detection. This is the use case that we are working with, but you can see it has multiple different examples that I showed you, as I showed you in the repository as well, but this is the one that we mainly focused on. So coming back to the repository, here we are. So what we did now, we did the first requirement, which is creating our sandbox, and now we're ready to go. It is talking about having your Kaggle username and key. So we already went through that, and I told you why we need this and where it's gonna get stored. Now, what we need to do, all those computes that we talked about, which are our silos, if I go back, to that Azure ML, let me switch my screen, there you go. If I go to computes, these are my silos. and each of them will have access to a portion of the data, not all data, right? So each of them we need to download that credit card fraud detection into silo 0, silo 1, and silo 2 to have a portion of the data accessible by these computes and let them do the model parameters updating stuff that we talked about in the whiteboard. Okay, so this is the first thing we're going to do, and how this is actually telling us how we can do it. So the repository that we clone in Azure ML, which we're going to come back to that shortly, under example folder, pipeline, utils, upload data, we need to run this submit.py. But before we do that, we should add some value for the parameters in the config YAML file, because we need to tell what is our workspace, what is the resource group, what's the subscription ID, and let this code knows where we are in Azure world and have the data downloadable there. So first we need to change to this YAML file, which is under this path. So let's go through that. Here's my Azure ML. We already cloned that using GitHub. So I think it was under examples. Let me double check. Pipelines, utils, okay. Examples, pipelines. Let me close the rest of the stuff. There you go, utils, upload data. And there you go. This is what we're gonna run, but before that, let's change config.yaml. Oh, you already changed that. Change your subscription ID, resource group name, and workspace name. Certainly you know these values. Paste them there. Plus, all the way at line number 26, you need to change this key vault URL with the one that you created. So for example, it's gonna be kv or key vault dash FL demo MG was the base name that I chose when I click on deploy, right? So make sure to grab that URL and based on the base name you chose when you were deploying your infrastructure with the deploy click. If you didn't change any other default values when with your infrastructure code pipeline, the rest should be the same. The name of the silo compute's gonna be the same that I just created, so I'm not going to change, and there's no need to change them. Then click on save. After that, what you need to do, you need to run this submit.py. So what this code gonna do, it will just simply go and call some helper functions and download the data set needed inside each blob storage in a silo using the silo computes. Okay, so there you go. Let's run this. I'll go to the terminal. How can I run it? This is actually the command line code. Copy, coming back to my terminal. Actually, before you run this, I apologize, you need to install some requirements as well. I think we skipped one step. Let me scroll the way up. There you go. You need to do some installment of the packages. For example, you want to call Kaggle. Kaggle should be installed, the Kaggle API. You can just immediately run this command line or create a sort of a virtual or Kunda environment through an environment YAML file that comes with this repository and then activate it. So you can do both. What you need to do, you need to run this command line under this path. So in Azure ML, let me close this terminal. Under examples, which is here, click on 3 dots and open the terminal here. And then if I go ahead, copy this, come here, click on paste. I don't need to go to examples because I am already inside the examples. So I remove this part and hit enter. There you go. It is starting installing the packages. I already installed them and run this demo before I record this video. So it is telling me requirement already satisfied. And now I think we are ready to execute the other code, which was submit.py that we were talking about. So let's double check. We already installed the requirements. We have the sandbox provision, and now we can run this command line. So you can just simply copy this, go back to the terminal, okay, let me make it a little bit smart. or actually create another one, because I don't think you see the end of this terminal. So let me create another terminal and close this one, terminate. All right. Now I need to change it to my subscription ID, change this to your resource group name, change it to your workspace, Azure ML workspace name, and that's it. You don't need to change anything else, and it knows which example you're running, which is the credit card fraud detection. So as soon as you run this, which I already ran this, what's gonna happen? I realized that in my pipeline, there was a new pipeline which is called upload data called created, and it has 3 steps or 3 sort of boxes. It is downloading the credit card fraud detection from Kaggle for each silo, silo 0, silo 1, silo 2. That means, coming back to our initial, now we got this data, we downloaded this data, we downloaded this data. All of them are coming from Kaggle. As an example again. And you know that each of them, they will have their own storage accounts that I don't have access to them. But let's quickly check that out. What is happening to those storage accounts? So I went back to my resources that I created under this repository, and you can see silo 0, silo 1, silo 2 is there in different regions, and the data set should be inside a portion of the data. As an example, should be inside these storage accounts, right? So when I click on any of them, again, because of that virtual networking access control in place, I cannot see them. But let's do a quick, not a good practice. On real scenario, I don't have permission to change the networking settings of these resources, right? I'm a data scientist as an example. But here, because that's my own environment, I can change it and show you actually what's happening on the backend. So let's quickly say that I'm gonna enable this storage account to be available by public internet, which is okay. I don't have anything in that storage. That's just a demo we are working with. So I click on save. Now I can go back to the containers and check what is inside this storage account. There you go. I got to know that it says I cannot access to that. Let me go back and see if I need to update anything else. Go back to the networking. Yeah, it seems to be okay. Let's go back. Yeah, there you go. I think it was not getting updated. So now you can see my train and test data sort of got appeared here and downloaded from credit card fraud detection. Perfect. Now, before we continue, let me go back and again disable it to access from public internet. Done. Okay, so what is next? Now I have, coming back to my whiteboard, which is super messy now. I have this data set here, and I have the compute, which are the compute clusters, silo 1, silo 2, we saw that in different regions, East US, Australia, so on and so forth. Now I want to initiate that training phase here, and training phase, and then have the results average here. Okay, let's do so. Now coming back to the repository, which is the place that I use it as my ground truth to follow what it's gonna tell me. So let me open that up. There you go. For running this demo, what I'm gonna do, I will just need to run another submit.py, which is under pipelines, credit card fraud detection, submit.py. And again, the same thing for running that. It needs my workspace name, resource group name, and subscription ID. So the same thing that I showed you in Azure ML terminal, you can run this, but let's quickly see what's gonna be happening there. There you go. Now I am under pipelines, example pipelines, and CC fraud. You see submit.py, and again, make sure you change another config.yaml information here. What you need to change here, again, all the way on the top, change these values, as we talked about that already, and the same keyword that I talked to you about, which is all the way at line number 82, change it to your key value URL. That's it. You don't need to change anything else. In case you want to, let's say, enable confidentiality, which gonna do encryption as rest, you can change line number 81 to true, but I keep them as is. For model training, it will give you multiple choices if you want to have simple linear, simple LSTM, but for me, and the default was LSTM, so I have it as is, and I didn't sort of change anything else here. Okay, now this code which we're gonna execute, we'll sort of start initiating, create actually pipelines, connect to Azure ML, create pipelines, and run that training over a portion of the data in different silos, 1, 2, 3 in parallel, have the results aggregated, do it again, I think through 3 or 4 different iterations through this pipeline and specify in this YAML. And it will do also pre-processing and doing some analysis, and then doing the training and aggregation that we talked about. You can see it is making them as a component, which is a new capability in Azure ML as well. So after running this and you know how to do so, you just need to go to your terminal. You say Python examples, pipelines. You don't need this. Delete utils and delete upload data. You just need to change these two parts with cc fraud. That's it. To change the path and run submit.py. Then what happened? I went to pipeline. I realized that now the second pipeline got created. And yes, that pipeline seems a little bit scary at the beginning, but don't worry, it is simpler than than what you think. Okay, so let's go one by one. Okay, here you can see in silo number 0, silo number 1, and silo number 2, I am doing pre-processing. So what is happening here? I am inside these silos and I'm doing pre-processing and the model training under each of them in parallel. So I have the dataset coming in, dataset portion, a portion of a dataset silo 1, a portion of dataset silo 0, silo 1, and a portion in silo 2. These are different hospitals with their own dataset, as an example, that we are not sharing the data. So after doing pre-processing, then silo 0, 1, and 2, they'll do their own training separately and update the parameters. And then the aggregation gonna happen, which we talked about that here, to sort of average all these model weights, which is a PyTorch model weights, it seems so. Then the model, which now we have this sort of purple average parameter, gonna get shipped back to these silos to do further training. Again, 1, 2, 3, silo 0, silo 1, silo 2, and again we have the model parameters aggregated in the second iteration. We do it again, ship it back for training, and again we aggregate that for the third iteration. I think after fourth iteration we will have the latest one, which is 5, and that iteration 5 aggregated PyTorch models, we have our final model get created. So what we did the pre-processing and training in a different computes that they have access to different portion of the data, and train the final model without the need of seeing the data and sharing the data. And you saw that each compute was in a different region, and each compute was deployed in a different private endpoint with different sort of access to a different portion of the data. That's it. Now here's the question: what is the performance of my model when I do federated learning compared to when I have all data in one place in one compute training the model? What about the time? How much I need to wait to have that solution end-to-end deployed? Well, one thing I liked about this repository, they actually did this benchmark for us. So if I go back to that repository, and I think in the first page that they have here in README section, there you go, they have the benchmarks. Let's talk about that. So sort of 3 things they actually benchmark here. The first one is training overhead. We're gonna see what is the end-to-end time need for the model to get trained when we have federated learning compared to the time that we have all data in one place and we are not using federated learning. So for the use case fraud detection, you can see that when we have federated learning, the overall time compared to have all data in one place, which is the blue one, is lower. Why? Because we have multiple computers, are getting trained in parallel stuff. And also when we have a portion of the data, we had 3 silos, right? So let's talk about one of the silos and the portion of the data that silos has, and let's say to see how much one training of one silo gonna take is this orangish color, which is sort of very similar to overall FL because each silo is getting trained in parallel. So that means from overload and the time that it's gonna take, it's pretty reasonable, right? So about model performance, let's say here we have precision, recall, accuracy stuff. We can see with federated learning compared to having not federated learning, the accuracy is pretty close. Even actually, interestingly, here I have the federated learning accuracy higher compared to when we have data in a centralized manner. And for rest of the stuff, we can see other metrics. And lastly, scalability. It is simply telling us under each silo, each organization, institute, hospital, whatever, when you have more instances of GPUs, or here I think it's GPU, not CPU, yeah. If you have more GPUs, you can certainly decrease the amount of time needed for federated learning. So there's a linear pattern of the number of the GPUs that can be scaled in federated learning. That means you can still scale even federated learning through more instances of compute or even distributed training within federated learning. Alright, that's all. Again, federated learning can be a very complex scenario based on your requirement, and on the backend side it has much more stuff, but I wanted to make it as simple as possible in this video and just provide you an introduction about what is federated learning, and at least having something to get hands-on and see it in action. So check that out, this repository, and check out the other use cases and examples here. That's going to be a great place to start to learn and implement that in Azure ML and start making it further customized for your use cases. I hope you enjoyed the video and at least you understand what is federated learning and you know the place to start with if you want to implement in Azure ML. And looking forward for your comments in case if you have further questions or nice use cases. Feel free to share that in the comment. And even in case you have challenges with implementing that, you can quickly report within the repository, hoping that the team gonna be responsible coming back in case you came up with any issues within the repository. Hope you enjoyed this video, and that's all.
If you really want to be transformed, you need to live an intentional life. Most people don't lead their life, they just accept their life. And when you accept your life, you're living on things that they're not worthy of your time, effort, and energy. To go uphill, you need to be intentional. Nobody never went uphill by accident. You need to be intentional with what you do and who you are. Dream big, my friends, believe in yourself, and take action. Until next video, see you later.